Okay, welcome to Chapter 4. Chapter 4 is on probability and odds. We'll start with 4.1, experimental probability. Okay, again, this is another chapter dealing with statistics. Okay, and the first thing we're going to start out with is reviewing fractions, decimals, and percents, just some review. Okay, because when we're going to do probability and odds, we need to be able to convert fractions into decimals, and decimals into percents, and percents into decimals, and percents into fractions, and decimals into percents, and decimals into fractions. We need to be able to convert numbers back and forth. Okay, so what we'll do is we'll do some examples. All right, and let's say we have a fraction that is 1/5. Okay, we want to convert that into a decimal. How do we do that? Well, it's very simple. We take the numerator, the top number, and divide it into the denominator, the bottom number, 1 divided by 5, and we get an answer of 0.20. Very simple operation on the calculator. If we want to convert 1/5, which is a fraction, into a decimal, which is equal to 0.20, how do we convert that into a percent? Well, all we do is we take that decimal, 0.20, and we multiply it by 100, because the word percent means per 100. So we multiply it by 100, and we end up with 20%. So how does this all relate to each other? Well, think of a test or a quiz that you might have done. Let's supposing you get one answer correct out of 5, 1 out of 5, what would you get as a percent? Well, we know that 1 divided by 5 equals 0.2. We would do that on a calculator, and we would take that number and multiply it by 100, and we would end up with a mark of 20%. So that's basically how simple that is. One thing we also need to understand is that when we're starting out with a fraction, we want to make sure that the fraction is simplified. In other words, taken to its lowest form. So if I'm given a fraction such as 2/10, we want to reduce it to its lowest term. We want to make sure that we have the lowest number possible from that fraction, meaning that if we look at 2/10, we know that the number 2 divides equally into 2 and equally into 10. So if we were to take 2 divided by 2 and 10 divided by 2, because that is the lowest common denominator, we'd end up with 1/5. And most of this stuff, these simple fractions, you can do in your head, but it's very, very important that when we're going to be dealing with fractions, decimals, and percents, in preparation for learning about probability and odds, we have to make sure that the fraction is simplified. So if I had something like 3/21, you would look at that and you'd say, well, I've got a prime number, or I think I've got an odd number on the top and bottom. It's got to be in its lowest form, but we know that 3 divides equally into 21, if you know your timetables from grade 4. So 3/21 is the same as 1/7. Okay? So you must make sure that your fractions are all simplified. In other words, to its lowest form in order to do this. Okay, so let's just look at some examples of converting. Let's just go down a bit here, more on the page, of converting between fractions, decimals, and percents. Okay, so I'm just going to make a little chart here. Okay, I know the lines aren't the straightest. I'm going to divide it into 3 columns, and maybe we'll just do 4 or 5 examples here. We'll call this column the fractions column. We'll call this column the decimal column, and we'll call this one the percent column. Okay, so I'm just going to fill in some numbers. Let's say in this column I have 0.89. Here I have 67%. Over here I have 2 over 37. Over here I have 0.03. And over here I have 45%. So our goal here is to fill in from one of the numbers given to us what this number here is as a fraction, and this one here is as a percent. And if we're given a percent, what is 67% in decimal and as a fraction? So let's go and do the first one. Well, the simple way to do this is that if you're given a decimal, it's easier to convert a decimal into a percent first and then come back to it as a fraction. So the way we just convert a decimal to a percent is we just multiply it by 100. So we would take 0.89 and we'd multiply it by 100, and we would end up with, I'm going to run outside the column, we'd end up with 89%. Okay, well 89% means 89 out of 100, so as a fraction we would just write 89 over 100. And then we have to answer the question, is 89 over 100 as low as it can go? Is it a reduced fraction? And it is. No number goes equally into 89 and 100. So that is decimal 0.89 as a fraction, and that is 89% is decimal 89 as a percent. Let's do 67%. Okay, well, first thing we can do is let's take this 67% and let's make it a fraction, which is the same as 67 over 100. And there's no number that equally goes into 67 and 100, so it's in its simplified form. And so how do we find that as a decimal? Well, we just take 67 and we divide it by 100 and we end up with 0.67. Very simple. So let's look at 2/37. Well, the best thing to do is to just divide the numerator by the denominator. 2 divided by 37. Okay. So if you go to your calculator and just take 2 divided by 37 and hit equals, you get an answer of 0.05. Okay? And then how do we go from a decimal to a percent? We just multiply it by 100, and we end up with, if we have 0.05 times 100, we get 5%. 0.03, that's the same as multiplied by 100. We get 3%, and all 3% is the same as 3 over 100 as a fraction. We can't reduce that anymore, so we just leave it at that. Now we have 45%. Well, 45% is the same as 45 over 100, but we know that 45 over 100 is not a simplified fraction, is not a reduced fraction, so what number goes evenly into 45 and 100? Well, first off, we can see that 5 does. Okay, so 45 divided by 5 is 9, so this is the same as 9 over, and 100 divided by 5 is 20. And 9 over 20 is a simplified fraction. There is no number that goes equally into 9 and 20, so it's in its lowest form. And then if we want to find that as a decimal, well, we just take the numerator 9 divided into 20, and 9 divided by 20 equals 0.45. Okay, so that is how you convert fractions into decimals into percents, and percents into decimals and fractions, and decimals into percents and fractions. Very, very simple. Okay, now that we understand how to do this, we want to talk about probability. Okay, in particular, experimental probability. Now, what is probability? Well, probability is just a prediction of how likely it is that a particular event will happen. For example, a 70% chance of rain or snow today. That 70% is a prediction of the likelihood of it going to rain or snow. Or 4 out of 5 dentists like a certain chewing gum. Okay, the probability is that 4 out of 5 dentists would like something. Okay, so those are examples of probability. Now, experimental probability is just calculated on measuring occurrences in a sample data set or a running trial to find out how many times it occurs. Okay, it can be expressed as a percent, as a decimal, or as a fraction. All right, so the best way to understand experimental probability is to do an example. Okay, so let's say we have a hat, and in that hat we put a bunch of coins in there. Okay, let's say pennies, nickels, dimes, quarters, toonies, and loonies. All right, and let's say in that bag we have 10 pennies, we have 15 nickels, we have 5 dimes, we have 8 quarters, and let's say we have 6 loonies, and we have 2 toonies. Okay, so we got a hat with all these coins in here, and we're going to ask the question, well, what is the probability of us pulling out a penny when we have one pick? Or what's the probability of us pulling out a nickel or a dime or a quarter, a loonie, or a toonie? Okay, well, how do we do that? Well, what you do is you place all these inside of a bag, and you would stick your hand inside the bag and you pull something out. Now, if we want to calculate the probability of choosing a penny out of the hat, what you would do is you'd say, okay, well, I know there's 10 pennies in the hat, all right? So my probability of choosing a penny is the total number is equal to the total number of pennies divided into the total number of coins that I have inside my bag. So this is just equal to 10 because I know I put 10 pennies in the bag, and it's just divided into the total. Well, I have 10 pennies and 15 nickels, 5 dimes, 8 quarters, 6 loonies, and 2 toonies, so all of that adds up to, let's see, 10, 30, 38, 40, 46. Okay, so I have 46 coins in total. 10 of them are pennies. So if I was to stick my hand in there and randomly draw out a coin, what would be the probability of me drawing out a penny? Well, it would be 10 chances out of a total of 46. Okay, and this here, 10 over 46, is not a simplified fraction. I want to simplify it. So what number goes evenly into 10 and 46? Well, offhand, I can think of 2, the number 2. So if I was to divide both by 2, I'd end up with the number 5 over 23, because your fraction must always be simplified. So I would have a 5 in 23 chance of choosing a penny. Okay, that is my probability of choosing a penny. So what does this mean? Well, if I want to express this as a fraction, it's 5 over 23. As a percent, or sorry, as a decimal, okay, so as a fraction, this is 5 over 23. As a decimal, it's just 5 divided by 23, which is equal to 0.22 rounded to the nearest 100th. And as a percent, I just take 0.22 multiplied by 100 and I get 22%. So I could say that the probability of me choosing a penny out of this hat with all these other coins in there is 5 out of 23, or decimal 22, or 22%. Okay, so that is experimental probability in a nutshell. Okay, so experimental probability and review of converting between fractions, decimals, and percents go from page 143 to 153. So you can do the questions in the workbook up to page 153, which will take you up to chapter 4.2. Okay, good luck.